Oh yeah, we're going to talk about map scale. Map scale is important. Map scale. So when we talk about map scale, we're talking about the ratio of distance on the map to distance in the real tangible world. It's basically the ratio of distance on the map, distance on the ground. It is dimensionless. In other words, the centimeters on the top cancel off the centimeters on the bottom, so you can have that ratio could be 1 inch to 100,000 inches, or 1 mile to 100,000 miles, or it could be 1 aardvark to 100,000 aardvarks. It doesn't matter what the units are, it is a ratio. How do we use it? 10-kilometer run using a map scale 1 to 20,000. How long should the route be in centimeters? You can do math and figure out these things. This is not something that we would typically ask you to do in class, but we would expect you to understand that. So in another lecture, I spend quite a bit of time talking about this, but I'll go over it again here. When we talk about map scale, this gets confusing. A small scale map covers a really large area. A large scale map covers a really small area. And here we have three examples: 1 to 50 million, 1 to 500,000, and 1 to 5,000. At 1 to 50 million, it covers the entire contiguous continental U.S. Now, that's a big area. That's a large area. But if you look at the fraction, 1 over 50 million, it's a very small number if you divide it out. Hence, we call it a small map scale, or a small scale map. As you move up to a different number, 1 to over 500,000, it's in the mid-range. 1 to 5,000, it is zoomed in, if you will, much, much closer, showing a much, much smaller area. And the reason we call that a large scale map is, comparatively speaking, if you divide 1 by 5,000, the decimal number that you get will be significantly larger than the one you get if you divide 1 by 50 million. Scale and precision comes in a lot when we talk about maps. This is just an equation here that basically works out, based on the scale of a map, how wide a line is at a certain dimension. And so 1 inch is equal to 72 points, whatever that is. So if you have a line that is 3 points wide, and you work that out with a map scale of 1 to 100,000, da 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 da, it tells you that that 3-point line is 347 feet wide. Now, the reason this becomes important is someday you may be doing work that involves things like wetland remediation. In other words, we had to destroy a wetland to put in a road. So we lost an acre, we've got to build 2 acres of wetland, and you draw a nice map showing where the wetland area was, the 2 acres or whatever that you destroyed, or say 1 acre, make it simple. So you've outlined this 1 acre wetland that has to be, that was lost, and you put a 3-point line around the outside of it. You've basically just made a line that's 1,000 feet wide around your area. And so when people go out there to see how much you actually made or destroyed, if you use a really crazy wide border like that, it could lead to a situation where people will question the area that you're saying, because like they'll say the line goes all the way to here, and it doesn't. The line's just thick. Once you build the wetland, or you're trying to delineate where the wetland stops and starts, even with a 3-point line at this scale, you're looking at a 350 feet wide area. That's not super accurate. So you got to think about these things. Turns out when you make maps that involve any kind of litigation potential, These are things that you really got to watch out for. You want to make sure that when you draw lines, they're small and as exact as you can make them, because it has real world impacts on what people do. If you have a highway location and it's 350 feet uncertainty just because of the symbol, what do? Local roads have an uncertainty of about 115 feet. I mean, think about that. That's incredibly inaccurate, really, it is. How do we estimate? Oh, man, there's a bunch of different ways. This is the sort of back of the envelope, quick in your head kind of thing. So your map scale divided by 1,000 basically gives you the approximate number of feet for a 1-point line. So if you've got 1 to 5,000 and you divide by 1,000, it means that 1-point line is 5 feet, and so on. So this is an equation probably worth committing to memory. Map scale divided by 1,000 is the approximate precision in feet for a 1-point thick line. Source scale and display scale. This is another thing that confuses students from time to time. Geospatial data has a scale at which it was created, and it's relative to the source data that was used to generate it. So if it's an aerial photo and then you're tracing lines on it, the scale of the photo is the scale of the data. And that's why they call it intrinsic or inherited, because it comes from however it was collected. Now, display scale is an entirely different animal. You can change the scale of the display of your map document or of the data sets. Display scale is independent of source scale. So you can take data at one scale and look at it at another, and a lot of times what happens is we do that and we do it wildly incorrect. In other words, we take data that was collected at one extreme or the other and use it at the other. The good news is if you take data that has a very large scale, like 1 to 24,000, and you use it to generate things that are at a very small scale, like say 1 to 250,000, that works okay. It's only when you try to take the 1 to 250 and make something that's at 1 to 24 that you really start having problems. So I've talked about this before, or I'll talk about it again later. I'm not sure which order the videos are going to show in. Once GIS data has been created, it can be displayed at any scale, but the original scale does impact the precision and accuracy. Here we have the coastal area, and we're looking at the scale of it, and we got two different lines, and you can see how the scale generates a very different looking coastline. Resolution is the sampling distance. A larger scale map generally has finer sampling distance and a better spatial resolution, and so on. Where do you find it? Look in your metadata